Welcome to MAKE, Hands-on Intro to Engineering Design, a course taught at the University of South Florida.
This tutorial discusses the Arduino compiler, class definitions, and the making of libraries. Okay, let's remember the object-based code for the two flashing LEDs that we discussed in the last tutorial. So remember, we defined a class for digital output pins of the Arduino. So we had the public members, here the constructor, the begin, on, off, and status methods, and then the private members were internal variables or properties of this class. And then down here we had the member definitions. So here the methods are being defined. And then finally at the end we had the main Arduino sketch, where we used the constructor to make two objects of this class, one for LED1, one for LED2. And then we use these methods that we defined up there in the classes in the setup to set the output pins, and then in the loop to turn the LEDs on and off. And this is what happened, two blinking LEDs. So if you remember in the tutorial about the functions, we tried to put the class definitions into a separate tab, and it did not work. The compiler did not accept that, and we got an error message. And then we put the header file for that class, where all the methods and the properties are being declared, back into the Arduino sketch, while leaving the actual programming code for the class members in the tab, and out of a sudden it worked again. So let's try to understand this a little bit better. And on this slide here, there is a summary what the Arduino integrated development environment does when you click on the upload button. At that moment, the Arduino IDE starts compiling your sketch. And so what does that mean? So here you have your sketch in standard C++. This would be a C++ file. And the Arduino IDE then goes through a pre-compile step where it does a few things to simplify things on the user end. So there's a few steps are being performed in the background. One doesn't really see that. One of them is to produce declarations of all the functions that you use in the Arduino sketch, and then it sends that to the compiler. At the same time, if you use any Arduino functions, these are defined in a Arduino header file, very similar to a class header. There are also other standard C++ functions that are available. They are in other header files, and so all these header files now are being evaluated by the compiler, whether in case they're needed in the sketch, and then they are also compiled with the main sketch. If you use libraries or if you have tabs, then these are also being examined by the compiler. And if there are headers in those libraries or tabs, then they are being included with an include statement. We will learn about that in a few minutes. So all of this goes into the compiler, and then the compiler spits out a so-called object file. We don't see that as Arduino users. This is just saved somewhere on the hard drive. So in this object file, basically all the functions are being declared or have been declared, and now it comes to the point where we actually put the low-level program code into the file, and this is done in the linker. So what the linker does is it basically reads through the object file, and then it takes from some standard files, the standard runtime library that is part of the Arduino environment. It takes program code for all the stuff that was defined here in the built-in header files, and it puts it into the program file. And then it also takes the C++ code from your libraries or what you have in your tabs, and it also adds it. And so here in the linker, everything comes together. And then at the end, we get a executable file. And this executable file we also don't see usually as Arduino users. That is what is being uploaded to the Arduino when you see the LED flash. Let's work with this concept a little bit. This is the original LED flasher sketch that we used for the tutorial that discussed the use of objects. So up here we have the class header, and what we will do now is we will put this class header into a tab and then see if we can make this sketch compile. I saved it now under new name, class in tab. So let's see what we have here. So it made a new folder, and it put a new INO file named class in tab into that folder. Okay, so let's make this new tab and call it digital pin.h. H is the convention for a header file in C++. So you see already where this is going. So let's make this tab. That's interesting to see now what happened. Here in the LED flasher class in tab folder, we have now an additional file which is called digitalpin.h. So this is this file that corresponds to that tab. So every time you make a tab, you actually generate a new file in that folder. Okay, so let's copy that over. Copy, and we put it here. Yeah, let's not forget this here. So okay, and delete this, and this here also. So let's see if this works. No, it's not working, right? So it doesn't understand here now what these members are because the header is missing. But we can now use a new command. So the number symbol include, and then we include digital pin.h, so this new file that we just made, and we try to see if we will see now if this here compiles. And you see it is now compiling and uploading, and the LEDs are still blinking. So by using this include statement and this file name, we are able to basically introduce this header again from the file where the header is stored. So what this include statement does, it's very simple. It basically takes the entire file, and during that pre-compile stage, it simply replaces it. And then we can compile again, and all these member functions are then known to the compiler because we declared them in the header, and so the world is happy again. Now what still bugs is that we still have the C++ code here for all the members in the main Arduino sketch. We don't want that, because imagine if you have 20 classes for a lot of devices that are hooked up to the Arduino, then this would become pretty big depending on the complexity of all these member functions, or methods rather, and so it would be difficult to even find the main Arduino sketch on its own tab. So what would be really nice is if we could put all this here into that new file that we made. So let's try that. Copy and delete. Let's be bold and put it right in here. And let's see if this compiles. Oh my, it did not compile. So what is wrong? Well, if you look at the error message down here, it says output was not declared. And so output, that is one of those definitions that are part of the Arduino IDE. So they are actually defined in a library file that has a header file that is called arduino.h. So apparently this information now is missing, while the compiler knew it in the main tab. So this means in the main tab it is automatically included. This is one of those invisible files that are standard in the Arduino IDE, so we usually don't have to concern ourselves with that. But if we put things into this tab here, then it cannot understand it anymore, because apparently the tabs are evaluated independently, right? This is during this compiling phase where all the different files are being evaluated and everything is put together. So what that means is we have to include here the Arduino library. So we say include quotation marks arduino.h. So in that Arduino library, this is where we find all these special Arduino functions that you find on the Arduino website when you go under reference. Okay, let's see how this works now. And it appears the compiler is happy. So it's uploading, and you don't see it, but I see it. The LEDs are blinking happily. All in all, a pretty happy experience, I would say. What we achieved now is we made that additional tab. We were able to put our digital pin class into it in its entirety. So everything is now nicely separated into in this one file here. And we have our main Arduino sketch file that only contains the important commands for operating our LEDs. So the next step now is to make this file here universally usable for all Arduino sketches that you are working on. So not only for this one sketch where it is here now included, but for all sketches that you will make in the future with LEDs. And that brings us to making libraries. Making a library is pretty easy. All we have to do now is to move the content of this digital pin H file into a new file that we can put into the library folder that is in the sketches folder of the Arduino IDE. So for this, I'm gonna save this now under a different name so we can play with it. I'll be right back. So I saved it as a class in library. Everything is still the same, so let's have a look. So in make course sketches, we have now a new folder, class in library, and there's of course still the digital pin H because we still have the tab in there. So let me copy this now, and we put it here in libraries. I made a folder, make course library, for this occasion, and I put it in here. And now let's go back to the Arduino IDE, and let's delete this tab. No, not a new tab, I'm sorry. Let's delete it. Yes, I want to delete it. Okay, and of course now let's see if this still compiles. And we're back to the original situation where it's lacking the header of the class and it cannot compile all the because all the class members cannot be identified here. So obviously this file now being in the library folder, it is not being found anymore by the Arduino. So the issue here is is that when you include something, the Arduino always looks in the folder for the sketch first, and if it can't find it there, then it goes to the library file and it looks there. Unfortunately, the contents of the library file are parsed only when the Arduino IDE is being started up. So at this point, the IDE simply does not know that this file is now in the library folder. So I'm gonna close the Arduino IDE now and restart it, and then we'll try again. Okay, we're back. I restarted the Arduino IDE. Let's see if we can compile this now. And it is compiling again. So you see, by simply putting this digital pin.h file into the library, it finds it now and it can compile it again. So this gives you the opportunity to reuse this digital pin class for many Arduino sketches, and you don't have to have it in there as a tab. So there is one more thing. While this works nicely, convention in C++ is to split the header into a different file than the actual C++ code that defines the members of this class. So I will do this now, and I'll come back and we can look at the files real quick. Okay, what I did is now I split the header and the C++ code into two files. So let's have a look real quick what we have there. One of the painful things about the Arduino IDE is that once you have things in libraries, you cannot use the IDE as editor anymore. So you have to use a text editor or some professional C++ development tool. But here I'm just using the Mac text editor, and so here we have the original H file, header file, and you see there's only the header left. It's a little bit garbled now because I had to make the screen, make the width here a little bit smaller so I can show both in the window. And here now we have the new file, the CPP file, and there we have all the code for the class members. So let's see if this still compiles. And we get a compiler error. So let's see. One always should look at the first one, because all the following ones may be caused by the first one. So we need to scroll up here. So what we see here is it can now not understand the new CPP file, and again we have some declaration problems. So this means we will have to make an include statement again in the new CPP file, and digital pin tells us already that we need to include the header file in order for the compiler to be able to evaluate the CPP file. Let's have a look at the CPP file. Here it is, and let's now add include digital pin.h. So we include the header file now that the compiler can interpret all the members of that class. So let's not forget to save this, otherwise of course this would have been pointless. So saved, and let's go back into the Arduino IDE and let's see if this is compiling. Okay, and it is compiling again. So what we achieved now is we have a separate header file and a C++ file, CPP file, that contains all the member definitions. So the only thing we had to do was to include the header file that the compiler can interpret all the coding here. Okay, basically everything is working, but in order to turn these files now into more or less professional C++ libraries, we still have to do a few things to make these libraries compatible with each other. And so one of the issues is one needs to avoid that headers are being declared several times, and that means that one needs to put a preprocessor directive. This actually is also one here, the include. So a preprocessor directive in there that actually asks whether the header was already declined at another stage in the compiling process or not. And so this is done with an if-then statement. So there is if and def, and then we say here digital pin.h. So that needs to, no, actually this is a different syntax. So one uses an underscore h here in this case now. So if not defined, right, that's what that means, if and def, then we define and any good if-then statement has an end if, so we put an end if down here and we save this. So these statements basically, they prevent that this header is included multiple times during the compiling process. So let's see if this still works. I saved it, I think. Let's do that again. And let's see if this compiles. Okay, and it is compiling. So basically it was harmless what we entered there. So in this case also it was not needed, because of course we only include here once. And so in this small sketch that wasn't a problem, but you should make it a habit that when you make libraries that they always have this if-then statement in there. You're probably wondering why one does that with that split up between the library and the C++ code. So let's look at this one more time. The reason is that these header statements, they are basically platform independent, while in the CPP file over here we have statements that are actually specific to the particular Arduino situation that we have. And so what that means is, if you would port your sketch to another processor platform, you could keep your original program structure mostly, and all you would have to do is then to replace this low-level code here to make it fit the new platform where the code is being ported to. Let's summarize what we did in this tutorial about libraries. First, we started out with an Arduino sketch that had the class definition in the main sketch file, and then we put it into a separate tab, and we used the include statement to make the compiler aware that the class is now defined in a tab. And then in the final step we moved the tab basically into the library folder, and we had to include some more include statements after splitting the header and the C++ code into two separate files. And so after doing this, we ended up with a library that could now being used by different Arduino sketches, and the compiler would be able to always mix them together before the object file is being compiled. There's one more thing I need to mention about these two files. The Arduino IDE expects that the CPP file is in the same folder like the H file. You may realize that we only ever include the H file, but we never talk about the CPP file in our code. And so what is assumed by the IDE is that the CPP file is always in the same folder like the H file. And the finding of the CPP file is important during the linking process. Right, so this is then when the IDE wants to know where the actual code is, and this is where it looks into the library folder to find it. This concludes our tutorial about the Arduino compiler, class definitions, and the making of libraries. Thanks for watching.